Welcome back. In this session, we are going to discuss about the forward difference operator. So I start by defining it and then do some computations on it. So let's start by defining what we mean by a forward difference operator. So given a function y equals to f of x, then the forward difference of f of x is given by the forward difference of f of x is given by f of x plus h minus f of x, where h is this mesh spacing for equally spaced mesh points. X0, x1, x2, up to xn. So this is the main definition of the forward of f of x. And when you let x to be x sub k, then x plus h will be x k plus h. So we can write the forward of f of x sub k is given by f of x sub k plus h minus f of x sub k. Now, we are going to use a notation that f of x sub k is the same thing as writing f sub k. So forward of f of xk, just written by f forward of f sub k, will be, now when I let h to be 1, the mesh spacing to be 1, then this will be written as f k plus 1, and then minus f of k. So we are going to make use of this definition as the forward difference of f of xk. I remember that you can either use f or you can use y. So this is the same thing as writing that forward of y sub k is the same thing as y of k plus 1 y of k plus 1 minus y of k. So this, you can either use a variable f or you can use a variable y. You'll have the same interpretation. Now, this is what we call the first forward difference. Now we call the first forward difference. Now, let's see how to define the second forward difference. Now, second forward difference will be given by simply raising this operator to 2. So it will be 2 f sub k, which can be written as forward of fast forward of f sub k. So remember, 2 is the same as 1 plus 1, so loss of indices. So which be the same as forward of, by definition, this fast forward is f sub k plus 1 minus f sub k. So which will be f forward of fk plus 1 and then minus forward of fk. And you see what forward operator does to fk, it simply takes from fk plus 1 then minus fk. So forward of fk plus 1 will be given by fk plus 2, that's the next step, minus fk plus 1, and then minus, by definition, forward of fk is fk plus 1 minus fk. So when you open the brackets at this point, we get fk plus 2 minus fk plus 1 minus fk plus 1. Now minus is plus fk. And this implies that second forward difference of fk will be given by fk plus 2. Now minus will be minus 2 fk plus 1 So this is what we call the second forward difference. Now, similarly, let's define the third forward difference. So third forward difference, the power of the operator will be 3. Fk, now by definition, the same as forward of the second forward of Fk. Loss of indices 1 plus 2 gives 3. So this will be forward of, we have defined this one as Fk plus 2 minus 2 Fk plus 1 and then plus Fk. So when you distribute this forward to each of these terms, so this will give us forward of Fk plus 2 minus 2 forward of Fk plus 1 minus plus forward of Fk. Now, the forward of Fk plus 2 will be now, you go next step will be k plus 3. So it will be Fk plus 3 minus Fk plus 2. So Fk plus 3 minus Fk plus 2 minus 2. Now this will be Fk plus 2 minus Fk plus 1 plus this is Fk plus 1 minus Fk. This is just by definition. So the next result will be Fk plus 3 minus Fk plus 2 minus 2 Fk plus 2 minus minus is plus 2fk plus 1, and then plus fk plus 1 minus fk. So now collecting like terms, this implies that the third forward of fk will be fk plus 3. Now this will be minus 3 fk plus 2. Now this will give us positive 3 fk plus 1, and then minus fk. So we call this one the third forward difference. So this is called the third forward difference. So third forward difference. Now let's define the fourth difference, and then we shall actually make some generalization of fk will be forward of third forward of fk. So we should be forward of fk plus 3 minus 3 fk plus 2 plus 3 fk plus 1 minus fk. Now, this will give us forward of fk plus 3 minus 3 forward of fk plus 2 plus 3 forward of fk plus 1 minus forward of fk. So by definition, this will give us fk plus 4 minus fk plus 3 minus 3. This will give us fk plus 3 minus fk plus 2, and then plus 3 fk plus 2 minus fk plus 1 minus fk plus 1 minus fk. So when you open this, you'll get fk plus 4 minus, so this be minus minus, so be minus 4 fk plus 3. Now this minus and this minus will be positive, so 3 fk plus 2, this also be positive, so 3 plus 3 is 6 fk plus 2. Now these 3 times minus fk plus 1 will be minus 3 fk plus 1, then minus fk plus 1 will be minus 4 fk plus 1, and then minus minus will be plus fk. So this is the fourth forward of fk. So this is the fourth forward. Fourth forward difference. Now, if you check carefully these differences from what you have calculated, note that we said the first forward of f sub k is given by f sub k plus 1 minus fk, and then second forward, we have gotten the answer to be fk plus 2 minus twice fk plus 1 plus fk. Third forward, we obtain the answer to be fk plus 3 minus 3 fk plus 2 plus 3 fk plus 1 minus fk, and we have gotten fourth forward of fk to be fk plus 4, and then minus minus 4 fk minus 3 plus 6, this is what we have here, plus 6 fk plus 2 minus 4 fk plus 1, and then plus fk. So this is the answer we have gotten at this point here. So you clearly see that this pattern, this a pattern. The coefficient here is 1, coefficient here is minus 1. So this is 1, this minus 2, 1, 1 minus 3, and this is minus 1. So 1 minus 4, 6, minus 4, 1. So if you remember Pascal triangle, then you see some similarity in these coefficients in this expansion of these forward differences. So you can actually predict the coefficients of the other higher forward differences by using the binomial coefficients by simply alternating the signs. So you see, when we have first forward, we have coefficient 1, 1, but the only difference is that the first is positive, the next one is negative. If we have second difference, we have coefficient 1, minus 2, and then positive 1. Third difference, we have positive 1, minus 3, positive 3, minus 1. So this is 1, minus 4, positive 6, minus 4, and positive 1. So it means that then you can always predict the higher order forward differences by simply using the binomial coefficients and then alternating the signs. So the first one is positive, then followed by negative, positive, negative, in that order. So this is how we can find those higher differences. And from the trend, you can always use the coefficients in the binomial expansion to get the specific values of the higher order differences. So in the next session, we'll discuss the properties of forward difference operator to see how they can be used to simplify some problems. Thank you.